So one way to do that is to break it up into prime factors. So first, break up each into prime factors with what we call a factor tree. Okay? So what's one way? There's more than one way to factor some integers. Okay? What's one way that I could factor 42? 6 and 7. 6 times 7. Can I factor 7? No, just 7 and 1, so that's not going to help me. What about 6? 3 and 2. And I can bring this 7 down. So these numbers, I cannot factor 3 or 2 or 7 anymore. These are the prime factors of 42. Now we do the same thing with 90. What's one way I can express 90 as a product or as a two factors? 9 times 10. What's one way I can separate 9? 3 times 3. What's one way I can separate 10? 2 times 5. Can I bust those up anymore? No. These are the prime factors of 90. Okay, now why did I go to the trouble to do this? To answer the question, the greatest common factor of a set of numbers, we're going to be also doing it with variables, is the product of the common prime factors. So you look at each prime factor and you count them as many times as it appears. Okay, so 3 appears in the prime factorization of 42. Does it appear over here in 90? Yes, so you can put a little check mark there. 3 appears there, 3 appears there. So it's 3. Now over here we have a 2. Is there a 2 that appears here? So we check that off. And that's going to be 3 times 2. We have a 7. Do we have a 7? Nope. Now we go over here and we look. What about this 3? Do I count this 3? No, because we have 90 has 2 factors of 3, but 42 only has 1, so we only write down 1. And so the greatest common factor between 42 and 90 is 3 times 2, which is 6. Any questions on that? Let's look at some more algebraic-like examples. Find the GCF between, let's do 6a squared b c cubed, 9ab, 15b squared c. Now we don't necessarily have to go down to this prime factorization tree, but this just helps us kind of get started. So I showed you that, how you can do that for numbers. But what are all the factors in this term? 6. How many factors of a do I have? Good. So I've got 2 factors of a. A is a factor here. B is also a factor. C is a factor, and how many times does it appear? 3. How about 6? Can I break 6 up into its prime factors? Yeah, so I can rewrite this if I want. 3 times 2, a squared b c cubed. What about 9ab? 3 times 3, and then I've got an ab. Remember that AB means A times B, so A is a factor and B is a factor. And then 3 times 5, B squared C. Now what's the greatest common factor between all 3 of these? So we look and see what's common in all 3. So notice I've got a 3 in every single one. Okay, so that's a common factor. I have a 2 here, but I don't have a 2 anywhere else, so I just don't worry about it. I have an A. How many factors of A do I have here? 2, because it's A squared, right? So this is A times A, so it's 2 factors of A. I've got a factor of A here. Do I have a factor of A over here? No. So A is not a factor that's common between everything. What about a B? Got a B here. I've got a B there, and I have 2 factors of B here, which means B is common. How many times? How many times is it common between all 3 of them? Once. 3B. And then I have C. I don't have a C here, so I know C is not a factor, so this is my answer. 3B is the common factor, greatest common factor. Any questions so far?